Welcome back to the second part of the EquiPop flow and introduction in 3 steps. In this part, we'll look into the preparation of the data analysis to be used in EquiPop, predominantly the geocoded data, but also some mentioning about the new feature of geocoded friction data that could be used to create networks within the EquiPop running and the material. We'll start with a look at the Excel, and I've got a few tabs down here. The idea is of course to use a k-nearest neighbor approach, and k-nearest neighbor studies have been around for a long time, so this is nothing new. So finding the k-nearest neighbor is a task wherein all the distances to all neighbors are calculated, and that's not a problem if you got a small sample, but if you got a very large data set, so it's 10 million individuals, and you want to find the socio-economic composition, say for instance to the 100 nearest, what if you want to have it for the 100,000 nearest neighbors to everyone? You have a computational problem. And who would like to have that, you ask? Well, in this case, you've got a map, in fact, with the 500 nearest neighbors from every single individual in the country of Sweden. This is a map showing the HDI, a computation of life expectancy and so many other kinds of things. And for each little point, the leftmost is Sweden. These are zoom in on Stockholm, Gothenburg and Malmö, and to the right we got a blow up of the Stockholm section. Every single part here is a residential location, and of course sorting them and finding out the distance to everyone else is going to be a daunting task, so you need some other kind of method. Well, the solution is to grid the data so that calculation of distance no longer are needed. This is the basic principle. If you go for the ones called I1, I2, I3, I4, those would be the place of origin to which you want to get the summary statistics. And if you note, the distance to the J1, J2, J3, J4, named B in the end, are the same regardless of where you start. And the same goes for the one called A, J1A, J2A, and so forth and so forth. So if you gridify the data, you can actually you don't need to sort, you don't need to compute the distance. You actually know it simply because there is a predefined distance matrix for any set of boxes and units. This is also available in the original dataset. You can obtain the software from EquiPop, cultgeo.uu.se. You will see it in other videos as well. And this is a principle that was already there for the first version of EquiPop, but there's a few new things coming up in this version, the flow, that needs attention. First of all, what is needed? Well, data should be gridded, as we said. It has to represent data for a specific mesh that you decide. Is 10 times 10 meter equivalent? Might be. It might be that you can do with a kilometer data. It must be perhaps sometimes only meters. It's really the question that determines it. It should be one row per location, so you need to aggregate the data. So if it is a duplicate, the last will actually overwrite early entries. The data should be tab separated, not comma, not semicolon, but tab separated. But you can use any file suffix as you like. And there's at least 5 variables needed for an EquiPop run. And those are an ID. It should be numeric, doesn't need to be unique, could be a code of a municipality or a neighborhood. It needs a coordinate value, east and west, where you have a projected numeric gridded. It must be projected because in projected space all the distances between all objects are the same, or all of the gridded units. If it's not projected, it will not work as well. Of course, a coordinate for north-south. You will need some kind of a notion for the population that resides within this unit, or works, or whatever. It might be, for instance, as in this case, I've got the number 5, representing perhaps a number of individuals living in the area, or the square of 10 times 10 meter. The subgroup then could be the number of kids. It could be 3. So let's assume that we want to find out the number of kids, or the share of kids among the 1,000 nearest neighbors. Then we will start counting with the number 5 and then moving outwards in a radial fashion, or perhaps in a network fashion, until you've reached 1,000 individuals, and the number of kids within that same distance is the basis for the construction of the share. When that is done, it moves on to the next cell and redo the calculation. The principle for the gridded data is that if we just have a random set of variables where each x and each y are simply there as on a metric level, We want to round them to a 10 meter level. In the first case, as we can see, we end up with the same kind of statistic, 3655, 3655. But in the second one, we could see we got a slight deviation. As you can see, of all these on the column X round 10 and Y round 10, they all end on the digit 5. And the reason for this is that if this the 10 meter distance between the origin, the blue arrow is pointing to the lower level having 0, and 10 being the top, we want to aim for something that is in the midpoint, the X. And that is in fact 5 and 5. So you want to have a 5er in the end, you want to have a 5er on the end, both for Y and X. And look at this statistics. This is how we construct this kind of a midpoint value creation in Excel, but you can probably use it or do it in any kind of a software. It's important to remember, when this is done, you need to aggregate the data. In some sense, you might have the gridification and truncation of data constructing fewer cases, and in fact, that you would have in the original state. This is what a traditional data file looks like. It could be yours, it could be mine, it could be anything. You need something that defines the area. You need something that defines the east-west coordinate, the north-south. In this case, it is the Swedish reference system RT90. You need something that counts the individuals. And then you can have a choice of these kinds of variables that you want to measure. It could be the number of poor people according to the European Union definition, the opposite, the number of wealthy ones, the number of working ones, or perhaps the number of visible minorities. This kind of statistics is then on the basis where you're using the count tool to actually reach the k nearest neighbors, and these ones marked with green are the ones used to define the share among the k nearest. The geocoded doesn't need necessarily to start with a habitable point. If you add the number 0, it actually starts counting from that as well. So the green one indicates a location where there is no one living, but the number 0 means that you're still constructing values. So if you want to do statistics for a long time series of years, and you perhaps in any of these years don't have population and a specific indication or point, you could add a 0 and make sure that that point is also covered and could be compared to later years. This one, however, being marked as we speak now, is not going to be counted for because it has no value. When it comes to the friction value, it is literally a method of letting or forcing the engine to stop doing the calculation for this round and perhaps do it a few more other times. If you got the number 1, it means act now. If it says 2, it means not act now, but wait one time. For each of the time the counting or the EquiPop engine actually reaches one of these, it reduces, so it takes away and make the 2er into a 1er. If you've got some value, in this case the number 5 being the highest one, it becomes also automatically the default value for all the missing. So you don't have to make a set where you got every friction for every part. You can solely define the friction for all the spaces where you got roads, for instance, or urban landscape, or where people can go around, and where you have one value for the highest one. It will be observed by EquiPop software, and it will be superimposed on all the void spaces. However, it's necessary to know that the calculation of friction data takes some time, should be done in a proper GIS software, but it is not necessary to run EquiPop. This is an option that makes it possible to run a network kind of analysis. If you do not use the friction data, you could still use EquiPop, but the growth will be on the basis of a radial growth. And what does the data file look for in the friction one? Very simple. You got the X, you got the Y, and you got the friction. And please take note, these values are always the same as the one being in the original data file. So the coordinates should be the same kind of logic and the same kind of number. It doesn't need to be the same coordinate precisely, but at the same equivalent distance, so they would match the same grid. As you can see, they all end on 50, and in this case, they all end on 50 because they are part of the same kind of a grid system. Now, how to think of this in a more sort of automatic way, how to calculate and what to look for? Well, if you think of friction as a speed of mobility, it doesn't need to. It could be a mental or any kind of friction, in fact, or cost, perhaps. So if you think of it as a maximum speed of 100 km derived from the road network, well, if you don't have to wait, it means that you actually are running on 100 km an hour. If it waits for a tour, it means that you reduce it by 8, then you have 80, 60, 40 and 20 kilometers an hour. It's simply that kind of an easy, divided by the number of units. If you got 5, 100 divided by 5 makes the minimum unit, and then add them all together. That also counts for if you've got 10 as the maximum, you instead reduce it by 10 each time. So from 100 to 90 to 80 and so forth and so forth. Well, this was the basic principle of it. If we look for the proper files, this is what the friction file looks like in reality. In this case, just open up in a big notepad file. As you can see, I can scroll down and scroll down and scroll down. There's quite a few numbers for a few locations. In this case, I think there are more than 40,000. And in this one, in the last case, you've got the population that I'm going to use. This is the area code, east, west, north, south, count all, and a few of the variables being included that could be for the study. And these are all the numbers. And as you can see, as I scroll down, all these numbers are being repeated. This is how you manage and work with the material for EquiPop. So when everything's ready, export it in a text format that is tab separated and import it in the EquiPop software. And the EquiPop software will be shown in the last round of this series, the 3-episode series. So welcome back for the final part.